Hey guys, so our topic for today is linear regression. Make sure you have that and today's date filled out in your table of contents. The first thing that we're going to do is I'm going to go over some basics in the calculator with you. The first thing that we're going to go over is entering data. I'll show you how to turn your plots on and then how to view a scatter plot in your graphing calculator. So the first thing that you want to do to enter data is we're going to go to the stat button and then we're going to hit enter right there where it says edit. If you have anything in your L1 and your L2, the first thing we want to do is clear that out. So if you go up and highlight the L2 and you hit clear and then press enter, it will go ahead and delete all of those values for you. And I'm going to go over and up to L1 and do the same exact thing. What's really important is to make sure that you don't hit the delete button. That will actually delete your entire column. So just make sure you're hitting the clear and not the delete button. When you're working with a set of data that has years, what we want to do is let the very first year in your table be 0, as I've written here in red. This will make entering the data a lot easier as well as working with the data. So if we're letting 1980 be 0, then 5 years later we would be at 1985. 1990 is 10 years after 1980, so that's why we're going to use the value 10. 1995 is 15 years later. 2000 is 20 years later. So what we're going to do is in L1, we're going to enter all of the X values. So we're going to enter 0 and then press enter. 5, enter, 10, then we have 15, and 20. So all of our X values are in L1. So we're going to go over to L2. In L2, we're going to put all of our Y values. So we have 14, then we have 20, 22, 28, and 37. What's really important is to make sure, first of all, that you entered all of your data correctly. So just check back over it and make sure you have everything in there. And then you also want to check and make sure that you have the same number of numbers in L1 as you have in L2. Sometimes you might accidentally have an extra number in one of your values. This will actually create an error in the calculator. So make sure you can clear out if you put an extra value in. Delete that number. Alright, so once you've entered the data, the next thing you want to do is turn your plots on. So if you go to y equals, if you have anything in your y equals, go ahead and hit clear. A shortcut for turning your plots on is looking up at the top where you see plot 1. If that is highlighted, that means your plot's turned on. So for example, my plots are already turned on. If your plot is not highlighted, so plot 1 is not highlighted, that means your plot is off. So if yours is not highlighted, you need to press your up arrow so that your cursor is blinking on plot 1. Press enter and then go back down, and now you'll see that your plot is turned on, that has been highlighted. So the next thing that we want to do is to actually view our scatter plot. Since our plot is on, we're telling the calculator we want it to plot the data that we just put in. So to actually view the scatter plot, what we want to do is we want to go to zoom, and we are going to go down to number 9. Number 9 says zoom stat. Once you've chosen that zoom, press enter, and you can actually see the graph of all of our data points. This is something that you will need to know how to do for graphing scatter plots as well as finding regression lines, which we're going to do in just a moment. The next thing that I want to show you in the calculator is how to turn your diagnostics on. What you need to know is that the R value is called the correlation coefficient. This is just an indication for us of how well our linear regression line, also known as a line of best fit, is fitting the data. Once you turn the diagnostics on, you won't have to do it again unless you clear the memory in your calculator or manually turn off the diagnostic. So in order to turn that on, we're going to go to second quit so we can go back to our home screen. To turn on the diagnostic, we're going to hit second, and then we're going to go to catalog, which is 0 down at the bottom. We're going to scroll down until we get to diagnostic on. You'll notice it's in alphabetical order, and that would be a lot of scrolling. So you can keep scrolling, or you can come over here and find the D, since diagnostic on starts with D, and we're going to press that button, and that will go ahead and skip us down to the D's. Now, if I scroll down more, I'll get to where it says diagnostic on. So once you find that, you just want to press enter. It will show up diagnostic on your screen, and press enter again. So now our diagnostics is on. What that will do is allow us to see our correlation coefficient when we calculate our regression line. So now that we have that done, let's clear our calculator to start with a fresh screen, and we are going to go to our first example. So example 1 says students at WEX were surveyed to observe correlation between the amount of time a student spends studying and their average in math class. In the table, we have the amount of time in hours a student spends studying per week. That's going to be our X value. In the next column, we have our Y values, which is the math average. The first thing we're asked to find is a linear regression model. This means we're trying to find the line of best fit for this set of data. The next thing that we are going to find is the correlation coefficient. Remember, that's the R value. And then we're going to use the linear regression model to predict the math average of a student who studies for 6 hours per week. So the first thing that we need to do is put the data in the calculator. So remember, to put data in, we're going to go to Stat. We're going to hit enter on edit. We'll go up and highlight L1, and we're going to hit clear. We're going to go over to L1 and hit clear. And in L1, we're going to put all of our X values. So we're going to put 8, 7, 10, 2, and then 0. Over in L2, we're going to put all of our Y values. So we have a 90, an 80, a 98, a 70, and a 64. Once you have all of your data in, go ahead and double check it. Make sure that it's correct. Also, make sure you have the same number of numbers in L1 as you have in L2. If not, you'll get an error. All right, what we want to do next is actually calculate the linear regression model. To do that, we're going to go back to Stat. We don't want to edit anything. We've already put in our information. So we're going to go over to Calc. We are doing linear regression, so we are going to go down and choose number 4. So we'll scroll down to number 4, and we're going to press enter. Now, your screen might look a little bit different than mine. Different versions of the calculator will have different things. Yours may have a line down here that talks about L1, a line that says L2, and then something that says store the regression, and then a calculate button. So what we're going to do is we are going to tell our calculator to go ahead and store this equation. So to store the equation, if your calculator looks like mine, you're going to leave the cursor where it is. If your calculator says store down here, then you want to scroll down and do this right there. So what we're going to do is we're going to hit vars. We're going to go over to y vars. We'll hit enter on function, and we'll hit enter on y1. And again, what this is doing is it's calculating our linear regression, and it's going to go ahead and store it in y1 so that we don't have to enter it in there. And then we'll press enter. So here the calculator is taking y equals ax plus b. This is just like the y equals mx plus b that we've done in class. It tells us our value for a and our value for b. What we want to do is plug in a and then plug in b. So we're going to round a to 3 decimal places. So we have 3.219 that we'll put in place of a. And in place of the b, we're going to do 63.01. And then we have to round this 6 up, so that will become a 7. So the linear regression model looks just like this. For part B, it says what is the correlation coefficient? The correlation coefficient is our R value. So all we have to do is look at the calculator and we can see that this is our correlation coefficient right here. So the correlation coefficient rounded to 3 decimal places is 0.973. Now that we've found our linear regression model and the correlation coefficient, let's take a moment to look at the graph. So we'll go to y equals. You can see that the linear equation model has already been typed in for me. Plot 1 is highlighted, which means my plot is turned on. So we need to go to zoom, and then whenever we're doing data like this, we're going to do number 9, which is zoom stat, and we're going to press enter. Now we have the graph of all of our data points, as well as our linear regression line, also known as our line of best fit, already drawn in here for us. So if you were asked to sketch the graph, this is what you would give. So now let's look at C. C says use the linear regression model to predict the math average of a student who studies for 6 hours per week. What you can do is plug 6 into this equation for x and solve for y. However, keep in mind that we rounded these numbers, so you won't have a totally accurate answer. For a more accurate answer, we're going to use the calculator. So what we're going to do is we're going to hit second, and then we're going to go to table. This will give us a table of all of the values. So remember, the hours studied per week is our x values. So in the x column, I'm going to scroll down until I get to 6. The y values is the average in math. So if I want to know the average of someone who studies 6 hours per week, I can look here and it's 82.331. The problem says to round to the nearest whole number, so I know that person's average is approximately 82. Now, this works the other way as well. If I was asked to find the average number of hours a student studies per week, if their average in class is an 82, I could go and look at my y values, find when y is 82, and see that that corresponds to 6 hours per week. So just keep in mind that it does work both ways, whether you're trying to find an x or a y value. The table is very handy. That is the only example that we're going to do as a class right now. Keep in mind that you can rewatch this video. You should have all of the notes as well as the steps written down in your notebook. What I'm going to give you next is actually an example for you to try working. In this example, you're given the age of children as well as their average height in inches. You are going to calculate the linear regression model, the correlation coefficient, and then you're going to use the linear regression model to predict the average height of a 5-year-old child rounded to the nearest whole number. This question should be worked in your notes and brought to class tomorrow.